So turbines, now we'll be discussing about the new topic called as turbines. And turbines are a kind of hydraulic machines. We all know that for a fluid, whether it's a liquid or gas, it has got some energy. We know that the energy that a liquid possesses is its datum head, and it has got its pressure head, and finally it has got the velocity head. So these are the three energy that a liquid or rather a fluid possesses, and this constitutes the total energy of a fluid. And the fluid has all these energy, total energy of fluid. And the purpose of turbine is to convert this energy of the fluid to mechanical energy. And this, so I can say the turbine is a hydraulic machine which converts the energy of a fluid into mechanical energy. What happens is you have a liquid, flowing liquid. In our case, in civil engineering case, the liquid will be flowing. So flowing liquid we have got flowing liquid, and this flowing liquid will be having some energy. That energy will be taken up or rather extracted by the turbines, and it will be converted to mechanical energy, and that will be given to a generator. That mechanical energy will be given to generator, and generator converts this mechanical energy into electrical energy, and that's how electricity is being produced. This is how you produce the electrical energy, and it is through this turbine that the mechanical energy or the flow of the liquid, the energy of the flowing liquid gets converted into the electrical energy. So turbine gives that mechanical energy to generator, and generator develops the electrical energy. So now comes the types of turbines. There are different types of turbines. I'll be discussing about one type of classification, and one type of classification is based on its working principle, on what basic principle the turbine is working. So based on this working principle, the turbine can be classified on the basis of working principle. It's classified as impulse turbine and reaction turbine. So you have got two types of turbine on the basis of this classification, the basis of working principle, impulse and reaction turbine. So what happens in impulse is that a large force is being applied to the turbine, and that causes the turbine to move. And that happens, just assume that you have a wheel like this, and you have some sort of arrangement wherein which you have some buckets. These are called as buckets. So you have buckets like this. So this is free to rotate about this axis. So what happens if I am just giving a jet of water through a nozzle like this? The jet of water comes and hits it. As soon as it hits it, it will be giving that force, or the large force will be applied into this. That causes this to move to this direction. So this just moves in this direction, so that the new bucket will be coming at this position. Again, that will be given an impact by the jet of water. Again, that will be moving. That causes the whole wheel to rotate like this. So here what happens is, it is the impact of water that causes the whole thing to rotate, and this is an example for impulse turbine, and this whole thing is called as Pelton wheel turbine. Pelton wheel turbine. Now coming to reaction turbine, here also you'll be having a rotating part, but here we don't have any buckets like things. We have some veins like this. You have some veins like this through which water will be allowed to either radially get in or radially get out. If you are having radially inward flow, the water will be entering from the periphery and it will be coming out from the center. Otherwise, if it is radially inward, the water will be entering through the center portion and it will be coming out radially outwards. So I'm just taking this vein. So what happens if the water is entering like this? The water will be coming and entering. As soon as it is entering, what happens is that this is the area. The area is decreasing. So as it is moving inside, what happens? The velocity is changing. The magnitude of velocity is changing. The velocity magnitude changes. At the same time, if you see, what happens is the direction is also changing, because see, it's slightly curved. Since it is slightly curved, the velocity has to change its direction also. So the velocity direction also changes. Velocity is a vector quantity, so it has got both magnitude and direction. So it changes both in magnitude and both in magnitude and direction. So we have learned in the previous semester, if you have something, if a flow of liquid, and if the velocity is changing, of course there will be some momentum change. If momentum is changing, it will be causing a force. So there will be a force exerted on this vane. If you take this portion, since the velocity is changing in both magnitude and direction, there will be a force that is exerted there. That causes the whole thing. That's the reaction actually. So that's the water will be exerting a force on this vane. At the same time, the vane will be having a reaction on the water. And because of that reaction, this starts to rotate. And here it is not the impulse. Water is coming, and it's not because of the impulse that it is rotating. It is only because of this change in velocity, which is in magnitude and direction, that is causing the whole thing to rotate. And this kind of turbines are called as reaction turbines. The next type of classification of turbine is on the basis of direction of flow of water. So on the basis of direction of flow of water, the turbine can be again classified as tangential flow turbine, then radial flow turbine, then you have got axial flow turbine, last one mixed flow turbine. So these are the 4 classification of turbine on the basis of its direction of flow of water. So first we'll deal with the tangential flow turbine. So in this tangential flow turbine, what happens is the water will be hitting this bucket tangentially, and that causes it to rotate like this. Here again I am showing the example of Pelton wheel turbine. So I can say that the Pelton wheel turbine is an example for tangential flow turbine, as the reason is that the water that's coming from the nozzle will be hitting this blades, or rather the buckets, tangentially to it. So that's why it's called as a tangential flow turbine. So the example for tangential flow turbine is Pelton wheel turbine. So I can say that Pelton wheel is both a tangential flow turbine as well as an impulse turbine.
The old water wheel is the precursor to modern Pelton turbines. Wood water wheels have been used to extract power from flowing water and convert it into mechanical power since the 3rd century. Often, water wheels provided power for water mills, which used millstones for grinding wheat to produce flour. The water wheel has long been replaced by the Pelton turbine for several reasons. Because of their clever design, Pelton wheels are far more efficient than water wheels of the past. The rotational movement of the turbine is usually transmitted to a generator, converting kinetic energy into electrical energy. A series of spoon-shaped buckets is mounted around the edge of the Pelton wheel. Buckets are usually cast as one solid piece, which is necessary to avoid damage, such as fatigue failure. The buckets have splitters placed at the middle of them that divide the water jets into 2 equal streams. The divider splits the flow of water striking it and changes the direction of the water by almost 180 degrees. This allows the wheel to capture almost 100% of the water's energy. The water jet can reach speeds of up to 370 miles per hour, resulting in a very high rotational speed of the wheel. Pelton wheels can be operated with almost 3,000 rotations per minute.
The next type of turbine is a radial flow turbine. So radial flow turbine means the flow is taking place in the radial direction. It's not like this tangentially. Instead, the water will be entering into this turbine radially. So it's entering radially, or rather it will be leaving the turbine radially. So either you have radially inward turbine or radially outward flow turbine. So in both these cases, it's not in the tangential direction the water is flowing, it is in the radial direction. So if the water is entering from the periphery, what happens? All water will be coming and will be coming out from the center. So water will be coming out from the center, and there will be a tube which will be connected towards the outward, and that tube is called as the draft tube. So remember, if you are having a radially inward flow turbine wherein water enters from the periphery and it will be coming out from the eye, this is called as the eye of the rotor. The rotating part is called as the rotor. Turbine, this rotating part is called as the rotor. So water will be coming out from the center or eye of the rotor. The center portion is called as the eye. So as water is coming out, it will be taken out through a tube called as the draft tube, and the diameter of the draft tube will be gradually increasing. It is coming out, it will be gradually increasing the draft tube diameter.